Good day, students. Our lesson today, it's on Unit 6, Lesson 6, Dividing Radical Expressions. So the benchmark MA912 NSO 1.5, it says to divide algebraic expressions involving radicals. And these are your mathematical thinking and reasoning standards. These you do not have to write down. The learning target. I can divide algebraic expressions involving radicals whose radicands are monomials. And monomials simply means one term. So let's look at some guided instruction on dividing radical expressions. So Ariana used the quotient of powers law of exponents to simplify the square root of y over the square root of y. Her work is shown. So she did it where she broke down the square root to fraction exponents. So y to the 1/2 over y to the 1/2. And because we're dividing those fractions, you subtract your exponents. So 1/2 minus 1/2 gives us 0. So y to the 0 power equals to 1. So when dividing radicals with the same index, the quotient law of radicals is used to rewrite the expression. Each of the following equivalent expressions demonstrates the quotient law of radicals. So here are other ways. The quotient law of radicals. Square root of t over the square root of t. They simply equal that to one big square root where they put the t over the t, kept it as a fraction. Now t divided by t is equal to 1, so the square root of 1 equals to 1. In the next example, the square root of x to the third times f over the square root of x to the third times f. When you divide those under the big long radical, that equals to the square root of 1, which is equal to 1. So let's look at an example for ourselves. Complete the table to simplify the square root of 147 g t to the 8th over square root of 3 g to the 3rd t to the 4th, where g is greater than 0 and t is greater than 0. So in the first box, they want us to rewrite using the quotient property. So we're going to use the quotient law of radicals to rewrite these expressions. So one big square root symbol. Let's grab the pen here. Use the big square root symbol. And we have 147 times g times t to the 8th over 3 g to the 3rd t to the 4th. Now let's remove the common factors. We are going to divide 147 divided by 3. Still have that long square root symbol. 147 divided by 3 gives us 49. And I'm going to keep that in my numerator because the bigger number is in the numerator. Then let's look at our g's. This is g to the 1st divided by g to the 3rd. Remember, when you're dividing these fractions, you're subtracting the exponent for the same variable. So because I have more g's in my denominator, 1 minus 3 gives me 2, and I'm going to keep that g to the 2nd in my denominator. And then let's divide our t's. T to the 8th divided by t to the 4th. 8 minus 4 gives us 4, and I'm keeping that in my numerator because I have more of my t's in the numerator. So t to the fourth stays in the numerator. Now let's simplify the radical. Let's take the square root of 49, which is 7. So the square root symbol is gone now. Still in my numerator. The square root of t to the fourth, that's t to the second. Over, keep it as a fraction. The square root of g to the second is just g. So here I have simplified my radical. And it gives us 7t to the second over g. Okay, in our second example, we're going to simplify the cubed root of 32b to the second divided by the cubed root of 4b to the fifth, where b does not equal to 0. So let's rewrite using the quotient property. So I'm keeping my cubed root. Let's grab that pen again. I don't want that so big. Let's erase that real quick. Try that again. So we have the cubed root. We have 32b to the second. And because we're dividing, it's going to be a fraction over 4b to the fifth. Remember, b cannot equal to 0. So let's divide. Let's do what's under the radical first. So 32 divided by 4, that gives us 8. Still keep that cubed root. So we have 8. And I'm keeping a fraction under the radical symbol. Let's look at our b's. Let's fix this b right here. Okay, so b to the second divided by b to the fifth. Remember, you're subtracting those exponents. 2 minus 5, that will give us a -3. But because we're keeping it under the radical, we don't want negative exponents. So because I have more b's in my denominator, that b to the third stays in the denominator. Okay, let's try that again. There we go. Okay, so to simplify this radical, we're going to take the cubed root of our numerator, which is 8. The cubed root of 8 is simply 2 over the cubed root of b to the third. How many 3's can I get out of that b? Just 1. So my response, or my final answer, simplified, it's 2 over b. Now let's discuss why there is a domain restriction of b not equaling 0. So b can't equal to 0 because division by 0 is undefined. Division by 0 is undefined. Okay, so now we're going to look at some radical expressions, and we're going to rewrite them in equivalent forms and use the quotient law to eliminate radicals where possible. And then we're going to list the domain restrictions. So we have 4 examples here. Let's start with the first one. The cubed root of 54, a to the third, b to the fifth, over the cubed root of 16, a to the second, b to the second. So remember, we can write using the quotient law of radicals, quotient law of radicals. So we're going to have one big cubed root where we rewrite those examples. So 54, a to the third, b to the fifth, over 16, a squared, b squared. Then removing the common factors, we can simplify 54 divided by 16. Let's grab our calculator here. So I'm taking 54 divided by 16, or find the greatest common factor. Finding the greatest common factor, 54 and 16. So let's divide it by 2 first. So 54 divided by 2, we have 27, excuse me. So 27 and 16 divided by 2 gives us 8. Okay, so now we have a to the third over a to the second. That leaves us with 1, because remember, we subtract those exponents. So that's a to the first. And then we have b to the fifth over b to the second. Subtract your exponent. That gives us b to the third. So each of those we're going to take and simplify. So the cube root of 27, what number times itself 3 times gives you 27? That would be 3. So getting rid of the radical for that fraction, that gives us 3. Cube root of 8, which is 2. Now, we can't take the cube root of just a. That will stay under the radical itself. But we can take the cubed root of b to the third, which is simply b. And then we leave the cubed root of a as a part of our answer. So for that example, we have 3 over 2 times b times the cubed root of a. Our restriction, b can't equal to 0, and a cannot equal to 0. Okay, so let's look at the next example down here. So we're taking the fourth root of 32 We're experiencing some technical difficulties here. Let's erase that for a second. Okay, so we should have 32 w to the 6th z to the 3rd over 2 w squared z to the 11th. So we will first divide 32 divided by 2, which gives us 16. Still have the fourth root. Okay, let's fix this here real quick. Erase that for a second. Let's go back. So the fourth root, 32 divided by 2 gives us 16. And then taking w6 over w to the 2nd, that gives us w to the 4th. Okay, it's not working so well. Let's erase that. Okay, w to the 4th. That's going to go over because our z to the 3rd is at the top and z to the 11th is in the denominator. We'll have z to the 8th in the denominator because more of my z's are in the denominator. So now we're going to take the fourth root of these numbers. So the fourth root of 16. So what number times itself 4 times will give you 16? That would be 2. The fourth root of w to the 4th is just w over z to the 8th, the fourth root of z to the 8th, that's z to the 2nd. This would be your final response. Now, your restrictions on this, w is greater than 0, and z is greater than 0. Let's go to the third example. We have the square root of 96 r to the 3rd over 3 r to the 4th t to the 2nd. So they've already given us the long radical. So we simply divide 96 divided by 3, which gives us 32. So we'll have the square root. So 32 r to the 3rd over r to the 4th gives us r in our denominator, and t to the second is already in the denominator, we leave it there. Okay, so now we need to take the square root of 32. Now we know 32 is not a perfect square. So we have to find two numbers we multiply to get 32. One of those numbers should be a perfect square. So we know 16 times 2 gives us 32. And we leave RT squared in our denominator. So now let's take the square root of 16. That would be 4. The only other thing we can take the square root of is that t to the square. So t squared, the square root of t squared, is simply t, and we keep that as a fraction because it's in our denominator. And then everything else is left in the square root. So that will be the 2 over the r. So for this one, our restrictions are t is greater than 0 and r is greater than 0. Okay, the last example, this is a you-do example. I would like to see this done when you come to class after watching this video. Make sure any questions you have when you come to class, please ask those questions. Thank you so much for listening. Have a good day.